In this video, I'll be talking about how to get the axis of symmetry as well as how to tell the domain and range for the functions. So, in the last video, we talked about how to find the vertex and how to graph quadratic equations and getting the x-intercepts and getting all that good stuff and plotting a couple points in. Now, the one thing that maybe I forgot to mention is that example where I had the two x-intercepts and finding the middle, and I told you that that was the x-coordinate of the vertex, and which makes sense because if this was at -4 and let's say this was at +8, then this middle value here would be at 2, because that's -4 plus 8 divided by 2. We talked about how that's average of the two x-intercepts, which means I have to add those two up, divide by 2, and you'll be able to get 2. So this value right here, it tells you your x-coordinate of the vertex, and you use that to find the y by plugging it back in. But not only does this tell you your x-coordinate of the vertex, it also tells you what we call axis of symmetry. The axis of symmetry is basically a line for a parabola, like a dashed line, that when you were to actually kind of fold, okay, pretend that that's like on a piece of paper and I fold it, it will be exactly symmetrical at that point. So this line right here would match exactly the same as this line right here. They will be matched up. So it's basically the halfway point. And because the vertex is like the turning point, or your max or min, it's like where it stops to start going down and it starts to go back up, right? So it's going to be something called a turning point. It's that like the point that's on that axis of symmetry or that folded line that creates the symmetry back up to here. So if you're getting confused about that, just remember that axis of symmetry is just the halfway mark of the graph. And because this is halfway mark of the x-intercepts, it happens to coincide with the axis of symmetry. So the axis of symmetry is the same thing as finding half of the two x-intercepts. In other words, finding the average of the two x-intercepts. So the general equation for axis of symmetry is given to us during the textbook, but I want to know why that is, which is -b over 2a. They always tell you that -b over 2a is what we call the axis of symmetry, and where did that come from? So suppose that I have two x-intercepts, and the two x-intercepts have been solved for every general equation by our quadratic formula. X equals -b plus and minus the square root of b squared minus 4ac over 2a. This is your general solution, which means general solution tells you no matter what type of quadratic you may have for different a, b, c values, you can always use this, plug it in and get your answers. So one of the solutions for the x that I will get is always going to be this. -b plus square root of b squared minus 4ac over 2a. The other one will be -b minus the square root of b squared minus 4ac all over 2a. These two would be my general solutions. So just the same way as I found the average of the two numbers, I'm going to do the same thing with the two quadratic formula equations that I have. So how am I going to do this? I'm going to take these two and I'm going to add them, and then I'm going to divide the whole thing by 2. Now this looks crazy, but it's not as crazy as it may seem, because you're adding this portion with the common denominator, which it seems fair enough to do. And not only that, this is a plus root b squared minus 4ac, and this is minus b squared minus a square root of b squared minus 4ac. The analogy that I did was use the blah, right? So let's call this entire thing as plus blah here over 2a, plus -b minus blah here over 2a, the whole thing over 2. Now, if I were to just add these two, now it's easier to look at it as like blah, because rather than just writing all the crazy square root of b squared minus 4ac down, it's just better to see it as some sort of a shape like that. So it'd be -b plus blah minus b minus blah over 2a all over 2 again. And see how these two would just cancel out? And so you would get negative b and negative b, which is negative 2b over 2a over 2, which would give me these two would cancel out, negative b over a, but you divide that by 2. Same thing as saying divided by 2 on this side or in here, right? So then that would be negative b over a times 1/2, which gives you this. So the formula for the axis of symmetry is indeed negative b over 2a. However, the origin of where it came from all started from when we were doing completing the square to get to the quadratic formula and using the quadratic formula to get our axis of symmetry, which is negative b over 2a. Okay, so whenever I ask you to solve for the axis of symmetry for any equation, so for example, let's say that I give you 3x squared minus 4x plus 5, and I ask you to find the axis of symmetry, or your, the middle value of the two x-intercepts. You're simply going to plug it in. Negative b, or negative b over 2a is equal to negative, plug in b, which is negative 4, over 3 times 2. So this makes it positive over 6, 2 over 3. And I'm done. And the axis of symmetry always has to be notated as x is equal to 2 over 3. Because if I plot x equals 2 over 3, it becomes a vertical line. Any vertical line is plotted along x is equal to something. So x equals negative 1. You go to x equals negative 1, and you plot all the points that has x equals negative 1. That's why it creates a vertical line. Okay? Because axis of symmetry for a quadratic parabola will always be a vertical line. Whether you have this shape or that shape, you will always have to notate it with x equals 2 over 3. Please do not just write 2 over 3. It should be x is equal to 2 over 3. Okay? Now, after that's finished, because axis of symmetry is pretty simple, let's talk about domain and range. Now, domain and range is something that we learn since 7th grade, 8th grade, or even Algebra 1. It's basically just telling you, for domain, all the possible x values, and the range, all the possible y values. Okay? So now how do we determine the domain and range for any graph? First of all, you need a graph. See, I'm more of a visual person, but regardless of whether you're more a visual person or not, I always say you need a graph to find what domain and range of these guys should be. So let's just say that I give you a graph that looks something like this, and this right here, or your vertex, technically this is your vertex. The vertex is at, 2, negative 10. Just arbitrarily, I'm giving you an example, let's say that. Now the domain for the x values for any quadratic will be very simple to do, because x is all real number. Now what does that mean? It means that no matter how much I extend this quadratic upwards, like you go infinitely this way and infinitely that way, your x will keep on going this way and this way. Like it will still continue to go, even though it might be incrementally very small. Like it will go very, very small, but it will keep on going, right? It's not like it's going straight up. It's going at some angle. So it will reach all the way, like all the way here and all the way here, right? So the x value is everywhere you go. There's going to be a possible x value for the quadratic. So no matter what type of quadratic that you're dealing with, whether you have this shape or this shape, all the x value is possible. X equal to 1, x equal to 2, or x equals negative 1, negative 2, x equals 1, x equals 2, x equals 3. They will always be present. All the x values are present for quadratics. That's a fact. No matter what. For a quadratic, it's always going to be existing. So you would say domain is all reals. This is what you're going to put down for your tests, for your quizzes. And it will say, notation for that, the abbreviation for that is 2 lines like this, and you go like R. This is a notation that says that it's all real numbers. Or you can just write all real numbers. It doesn't matter which one. So domain is 100% all reals. So no matter what kind of quadratic you get, you write domain as all reals. Pretty simple. Range is when it gets a little tricky. Now range, as we know, is all possible y values, right? So let's take a look at the same graph, the 2, -10. Now we know that the domain is all reals, but the range is not all reals, or it shouldn't be all reals. It can't be all reals because here it reaches a certain maximum or minimum point and it stops going down beyond this point. So in this particular case, notice how the graph is going upwards, infinite. So it is gonna go all the way up to positive infinity in the y direction. But in terms of down y direction, the lowest it ever reaches is -10. It does not go below -11, -12. You don't see any values present here. There's really nothing present here. So how do I represent my y values? Well, it's between the positive infinity and -10. So you would say your range is between -10 and infinity. Like that. Usually they notate it with little brackets, but we're not going to do that. You can just write it in inequalities, and that will be fine. Now, sometimes they will use this and this. This is notating that it is not including, and this means it's including. So to represent this as in these bracket form, you would write it like this. An infinity cannot be contained, ever, because it's arbitrary, it's just something made up. You cannot contain an infinite amount of numbers. So that's why you don't say it's contained, but the -10 is like included in that range value that's present up here, right? So we notate it like this sometimes. However, this is more appropriate answer for the test or the quizzes that I'll be accepting. If you write it that way, I'll also be able to read this as well, and you can do that. But it will confuse you with the new brackets and parentheses, so just use inequalities for now. What if I were to give you something upside down shape, and the vertex up here happens to reach +7? So let's say that this is -4, 7. That's -4, that's +7, so the vertex. So do I care about the x-intercept at all? No. You only care about the vertex. You only care about the vertex when it comes to range. So when it comes to the range of the function, you really just want to care about the vertex. So here, what do I say for the domain? All reals. Every time, all reals. Range? Well, it reaches down here. Do you see the arrows going down for quadratic? It reaches all the way down to -infinity, right? So you would say between -infinity to 7. Because the highest it ever reaches up to is 7. It doesn't go beyond that. There's nothing here. So your answer would be that. Well, the parentheses is not necessary. You can just write it this way. But this would be your answer. Domain and range. Okay? So pretty simple, right? Domain is all x values. Range is all your y values. And all you have to do is just take a look at where it's going, the direction. That's the way to go. For linear graphs, I don't know if you guys didn't have to do any domain and range because it's all reals for everything. If you take a look, for any linear graphs that you may have, it reaches all the way left and right, and it also reaches up and down, -infinity, positive infinity, -infinity, goes all the way this way, all the way up that way as well, because it keeps on going rise over run, no matter how you do this. Okay, that's just a side note. But this domain is all reals is very important. Also find the range always determined by the vertex. This is the most important. Okay.